Ashwin Kulkarni. Welcome you all to give a little bit glimpse about how quantum industry is going on and what is the significance of quantum computing in today's world. I hope all of you are doing great and everyone is safe around, and I hope you have enjoyed my previous two videos. They might be a little bit deeper sometimes, but let's stick to it and let's do this journey together. Okay, so let's get started. So this video is not going to be any particular concept specific. This is a generalized overview of how quantum computing is evolving in the enterprise industry and what is its current significance, right? So I have already explained what is a quantum computing, right? But why? Why it's quantum computing? So I might have already touched upon this topic that quantum computing is not here to replace the classical computers. Okay, this is here to solve a very certain set of problems that classical computer might be having a difficult time to solve. So a simple example for all of you guys is, let's say you need to find one simple element in set of 1 trillion elements, where going through each element takes, let's say, 1 microsecond. Then it would take 1 week to find that particular one element in those set of 1 trillion element. But on the contrary, a quantum computer can find it within just a second. Okay, so that's how beneficial it in some cases, or in other cases where quantum computers might be lagging, where your classical computers have an upper age. Okay, so I'm not calculating those examples here, but yeah, those cases are exist. Okay, so the real benefit of quantum computing, I mean, the real time examples are, let's say, you're finding a shortest route for your salesman problem in between cities to save a fuel. Okay, then another problem is finding a perfect solution to create a batteries so that we can create efficient batteries for electric cars or electric machines. Then another problem is in the crypto, sorry, in the cryptocurrencies where uh, you need to have a better algorithm for security. Another major real-time example of quantum computers is finding about Higgs event, where how our universe is originated. It is a study about that. So it is basically a study about particle physics theory. So a quantum computer may break through that particular study. The other real-time example is in banks. If we want to solve a fraudulent cases, then in that case also quantum computers might be helpful. Now, uh, now where our world needs to prepare in upcoming years for quantum computers is basically in a security domain. So, for example, you guys must be knowing the Y2K problem. So Y2K stands for year and 2K is 2000. So when 2000 year started, many system collapsed because they were using 1900 year codes in their systems. So suddenly those system collapsed because we have transitioned from 1999 to 2000. And similarly, because quantum computer were able to solve a Diffie-Hellman cryptic code. So again, a Diffie-Hellman is a security algorithm where is a cryptography based algorithm which is used in many security systems. So a quantum computer is able to solve that, and many of our systems are dependent on that particular problem. So now quantum computer is not as such deployed in a public domain, I would say. So these systems are currently safe, but let's say in next 5 years, those systems should has to be transitioned to much secured algorithm. Now, talking about the challenges of current quantum system, the basic challenge that current hardware is facing is about lack of entanglement, or it is getting decoherent very quickly. So what I mean by that is, so forget about entanglement. We are going to learn about it in upcoming videos. But essentially, the communication between two qubits is getting dissolved very quickly, and that's why we need to process a particular algorithm within that short time span. Now, the uh, another significant problem that currently these quantum hardwares are facing is about handling more and more qubits till it gets decoherent or till it gets decoupled with respect to each other. So the quantum entanglement is a very important concept that we are going to touch upon in upcoming videos. But basically you can just think about it is getting decoupled very quickly currently in our current hardware, and that's why the processing time should be very quicker before it gets decoupled. Now, since it has just started the proper actual development had just started few years back, so there is no baseline transistor which is created for a quantum computer. So what I mean to say by that is, different people, different companies, different researchers are trying different type of hardware to solve a particular problem. So there are different quantum computers which are based on different type of semiconductor combination. There are some quantum computers which are dependent on photons. So there is no strict baseline, or there is no a particular published baseline on which next few evolved system can build upon. But yes, I'm pretty sure in upcoming years we will get there and we will set some baseline results for a quantum computer, of course. Now, let's talk about some buzz around quantum computing and how industry is working on it. So there are quite a lot of companies have entered in past few years in this quantum computing journey. Some of them are focusing on quantum hardware, some of them are focusing on only quantum software and quantum on cloud, etc., etc. So there are many companies. Many significant companies which are working on this area. I'm listing some of them here so that you will get a crisp about it. So the first one, and which is well known about its work in quantum journey, is IBM. So they are quite a leading in this quantum computing space, and yeah, as you can see in 2016, it has become a first company to offer cloud-based resource for quantum computers. So where you can directly access the quantum simulators, you can run your algorithms, or even quantum hardwares, you can connect with them via your API token, and you can run your quantum hardwares, which will be in a queue, and eventually you'll get a result. Now we are going to see the roadmap, but significantly in last year, 2021, they are the ones who was able to cross the 100 qubit barrier in a single quantum system. Now, the another leading company is QCI. So they have a unique vision where basically they are not going to, of course, as I earlier said, they are not going to replace the classical computer, but they are going to complement them. So they have a unique packages where it is a blend of classical and quantum computers, where you can take leverage wherever a particular quantum compute is required. Otherwise, it just switches to the classical computer and perform your task. So also they are offering software as a service based quantum computers, where the companies can just use their software in a cloud format to perform their operations. Now, Xanadu is a Canadian startup which has also done impressive amount of work in a quantum computer. So as I already told you that there are different companies who are trying to build different base transistor for quantum computers. So Xanadu is the one which is trying to build a quantum computer based on the photon. And recently, I was reading some document where it is mentioned that the photon-based quantum computers are two times or significant amount of times better than normal semiconductor silicon based quantum computers, but I'm not pretty sure on that claim. Now, they have done a significant amount of breakthroughs in this particular quantum computing journey. Now, another popular name in this quantum computer world is Microsoft Azure Quantum. So, same as IBM Cloud, they are also offering a quantum computer services on Azure Cloud, where where they are offering a different resources, and also here on Azure Cloud, you can people can use different hardwares from QCI or Honeywell, which those companies are also working on. So they have a great amount of vision in quantum space, and they are also doing their work quite significantly. And another one which is D-Wave systems. So this is the first one where you can use a real-time cloud access for quantum computing resources, and they have a different leap on their in their quantum journeys. So the leap to of their particular quantum computer, which can leverage a hybrid version of quantum hybrid version of systems, I would say, where a classical computer and a quantum computer can blend together and perform certain tasks. So these are different big names and some of the startups which are working in this particular space, and there are again many different ones such as Honeywell, QCI, then Toshiba, I would say, then some energy related companies which are also collaborating with these names, or they are working independently on this quantum computing uh, hardware and software releases. Now, I just want to quickly show you about one particular company and their roadmap. Of course, there are all the companies which I have shown or talked earlier. They have their own roadmaps for a quantum computing journey, but this IBM Quantum has a very significant amount of roadmap in their quantum journey for next 5 years. I can say so. Starting 2019, they have started with 27 qubits. In 2020, they have reached 65 qubits and plus. Now in 2021, as I just now explained, that they reached a barrier of 100 qubits in a single quantum system, as they have reached 127 qubit Eagle quantum system. And now for 2022, they have a target of 433 qubits in a system, and where they have also target to minimize the error and improve the scalability and functioning of quantum computers. Now in 2023, of course, they want to increase it more than 1,000, and then beyond till 2030, they have their own roadmap of IBM Quantum System 2, where they want to have 1 million qubits or beyond in a particular data center of quantum computers. So that's how these big companies are working on quantum computers. Now, apart from this particular series, of course, there is ocean of knowledge about quantum computers. I'm just a single droplet into it, I can say. Now, there are many different courses available or different study material available for quantum computing. I'll be keep on sharing them in further videos as well with you. So from where I'm learning, from which particular book I'm reading about quantum physics or quantum computers. But some famous courses and easy to accessible courses are from edX, then some of them are from Coursera. Then also there is a particular course by MIT. They also have a they also have a significant amount of resource available on YouTube itself, and Also, they have their own course, paid course as well. Now, one another popular course for quantum computers is by IBM, where you can learn about it. And also, IBM offers you a particular developer certification program as well, which I have already passed last year. So this particular Qiskit certification program I offered by IBM, and it is based on the Qiskit. We are going to talk about it in later videos, but that is industry first developer certification for quantum. Now, again, there are different certificates available by edX or Coursera as well. You can go check them out. So there is quite significant amount of learning material available on internet for this quantum computer. There are paid and as well as free resources available, and for to expertise in them, there are different certifications are available as well. You can take leverage. Take their advantage as well. So this is it for today's video. I just wanted to give you a simple glimpse about why I have started this course and why we are doing this. So there is a significant amount of work happening in the industry related to quantum computing, and I just want to contribute something in this community. So I have started this particular series, and I hope you are going to get some knowledge out of it in upcoming videos as well. Thank you so much for your support in first two videos, and I'll see you in the next one. Bye, and don't forget to like, share, and subscribe this video as well.